Hello everyone. So we have come up with another numerical, and just I will read the text for you first. The mass of a ship's machinery is given by the formula m is equal to k delta 2 by 3 v cube tons. Okay, so this is the formula that is given for the mass of the ship. Okay, now the question says that a ship of 2890 ton displacement. Now the ship displacement is given and the speed of 14 knots has a machinery mass. Okay, machinery mass of 410 ton. So now the machinery mass is given as 410 ton. Now what we are supposed to calculate, the question has got two part. Calculate the mass of the machinery of a similar ship of 300 ton displacement at the corresponding speed. So the speed will remain same. Okay, now the displacement is different. Now if the 2890 ton ship required 2920 kilowatt shaft power, so this is the shaft power that is given. Calculate the shaft power required by the 3000 ton ship. So now that this says that, now what all we have given is the mass that is denoted by that formula. Then we have the displacement. Okay, so displacement is has in two cases, displacement 1 and displacement 2 for the other two, the two part of the question. Now this says that the speed is also given, that is 14 knots, and the mass is 410 ton. Now the shaft power is given is 2920. So we have to calculate the other shaft power, that is sp2. So now we are denoting the previous shaft power as to be this. Now so therefore, so as per this formula of the mass is we are putting here, and then we will calculate from here, we'll calculate the k. Okay, because the other things that are given, so we have put up the values in this formula. Okay, now so therefore the k will be how much is 410. So now it will be 2890 whole to the power 2 by 3 into 14 cubics. Okay, so now the k will come out to be is 7.36 into 10 to the power minus 4. Okay, now this is the value of k what we have seen. Now this will come handy for our further course of action. Okay, now first of all we will find the b part of the question. So which is says that if the 2890 ton ship required 2920 kilowatt shaft power, calculate the shaft power required by the 3000 ton ship. Okay, so now to find shaft power, so just bear with my handwriting. To find shaft power, when we are trying to find the shaft power, so we have sp1 by sp2 is equal to delta 1 by delta 2 whole to the power 7 by 6. Okay, because as we know that sp is directly proportional to delta to the power 7 by 6, and v is directly proportional to delta to the power 1 by 6. So this is known to us. So therefore now we have sp1 what is known to us. So it is how much, sorry 2920 by sp2, that will give out 2890 divided by, that is how much, delta 2 is 3000 to the power 7 by 6. Okay, so from here we calculate sp2 is how much, 2920 into, and then it will come out to be 3000 by 2890 to the power 7 by 6. So the sp2 what we get is 3050 kilowatt. That is the answer for b part. Okay, this is the answer for b part. So the shaft power required for 3000 ton of the ship is how much, 3050 kilowatt. Now we'll calculate the v a part. Okay, so as we have seen here, v is directly proportional to delta to the power 1 by 6. So here delta is denoted to by the displacement. Now v is directly proportional to delta to the power 1 by 6. Okay, now therefore what we have here is v1 by v2 is equal to delta 1 by delta 2. Now this whole power will come out to be 1 by 6. Now we have v1 which is given is 14 by v2 is equal to 2890 by 3000 to the power 1 by 6. Okay, now from here we will calculate v2. V2 will come out to be, so just we'll solve the expression, and it is 2890 to the power 1 by 6. Okay, now therefore m is equal to, so we have the formula m which is given in the question itself, 2 by 3 v2, and then you have cubics. So m is equal to, so k is how much, 7.36 into 10 to the power minus 4, 10 to the power minus 4. This k we have calculated in the beginning itself. Okay, 4 into the displacement is given in the b part is to be, a part is to be, and multiplied by the speed what we have calculated here, where we have calculated the speed, yeah, from this expression when we are solving. So this will come out to be, v2 will come out to be 14.08 knots. Okay, 14.08 to the power 3. So from, if you solve this expression, so it will come out to be 427.33 tons. So you see that we have to solve first. So now it is clear. Now from this expression we got the value of k. Now first we calculated the shaft power, then we calculate the shaft power, we analyzed from here. Okay, so sp2 we calculated, and then we had the expression. This is very important. Sp is directly proportional to delta to the power 7 by 6, and v is directly proportional to delta to the power 1 by 6. So it's from here v1 by v2 is equal to delta 1 by delta 2 to the power 1 by 6, and then we have analyzed here the value of v, and this value of v we have put up in the expression of what is known as the mass equation that is given in the question itself. Okay, and then we have calculated the 427.33, and this is supposed to be the answer of part A. Okay, this question has been asked in the exam several times. I won't name the year, so you can solve like this. Thank you so much.